The developed world is using more and more electricity every day. If we're to go on like this, we'll have to learn to make and use electricity as efficiently as possible.
I'll leave the door open. It's stifling in here. The air conditioner must be broken. Will you... You could try turning the heating from here. And what are all these things doing on anyway? Do you have any idea how much gas and electricity you are wasting? Well, I didn't have the energy to get up and turn them off. Do you know where power comes from? All the power that you are wasting. It doesn't just magically appear, you know. It all has to be made. It has to be generated. Yeah, I know. They make it in power stations, where every day they burn thousands of tons of coal to make high-pressure steam, to drive turbines, to generate electricity. Actually. Yeah, well. Just you remember it next time.
Most of the power we use comes from a place like this. It converts the energy in fuel into electricity. Power stations are pretty massive. It's much easier to understand them using a model. The first part of the model is a pressure cooker, with a tube leading from it to a propeller. The propeller is joined to a magnet, which can rotate inside a coil of copper wire. Finally, the two ends of the copper wire are connected to a voltmeter. They're burning gas as a fuel and using it to turn water into steam. In the 1830s, Michael Faraday discovered that rotating a magnet inside a coil produces an electric current in the wire. So they've converted the energy in the gas into electrical energy. Power stations work in exactly the same way, but this one runs on coal, 38,000 tons of it every day. Lumps of coal don't burn very efficiently, but coal does burn well as a powder. At the power station, they use giant crushers to produce the coal powder. It's then blown into the boiler, where it burns like a gas. The heat turns water into steam, which travels along pipes to a turbine. The turbine rotates a magnetor. Electricity from the generator is carried all over the country, and there's a huge amount of it. This power station on its own supplies 10% of the electricity for England and Wales. The model produces a bit less, even at full speed. How much of the fuel energy is being converted to electricity? If you aren't careful, a lot of it gets wasted. With a special thermal camera, hot things show up brighter. You can see that a lot of heat from the gas isn't going into making steam.
This box is inefficient because it's letting the steam escape, but if you were to cover it, then the steam will be trapped in a box where the energy can do some good.
With this pipe you could lag it, which would give you a higher steam pressure, which would turn the fan quicker, which would give you a higher voltage.
They're trying to make the model more efficient by stopping heat escaping. Using lots of thermal insulation, they should be able to convert more of the energy in the gas into electricity. It definitely looks more efficient with the thermal camera. There's far less heat escaping. After pushing the propeller, the steam condenses back into water, but there's still a lot of heat in it. If it just runs away, it's useless. But you could do something with it. In the real power station, steam passes through the turbine and then goes through a condenser. The steam loses heat energy and turns back into water. It can then be pumped back to the boiler to start the cycle again. Inside the condenser, the heat from the steam is transferred to cooling water, which then goes to the large towers you can see near power stations. The cooling water loses heat at the towers and then goes back to condense more steam into water. The warm water is sprayed in at the foot of the cooling towers, and a draft of air sucks the heat up to the top. Everyone thinks it's smoke that you see at the top, but it's only water vapor. You can't turn this heat into electricity, but the power station is made as efficient as possible by sending some of the warm water to heat greenhouses instead. They grow 3,000 tons of tomatoes here every year. Maybe you can think of other efficiency measures for the power station. What's the most efficient way to power a go-kart? With petrol or with electricity? Nicole has the electric go-kart. It's powered by a battery which runs an electric motor. The first thing she has to do is charge the battery. The charger is plugged into a joule meter, which measures the amount of electrical energy she's putting in. A fully charged battery contains 2,820 kilojoules. Scott is filling his go-kart with the same amount of energy. 90 millilitres of petrol contains just the right amount. The go-karts now have the same amount of energy, but which one is going to use it more efficiently? Which go-kart will go further if they keep to the same speed? Scott's keeping an eye on the temperature of his engine. But it hasn't done him any good at all. Nicole's electric go-kart is more efficient because the energy it needs is already in a very useful form in the battery. Scott had to extract energy from the petrol by burning it, and burning isn't very efficient. Let's see what the race looked like with the thermal camera. Only a few seconds after starting up, the casing of Scott's engine got very hot. But that wasn't the only place where heat was being lost. Nicole's car wasted much less heat, although some parts of the motor were warming up a bit. Are electric vehicles really more efficient? Think about where the electricity came from in the first place. What's the most efficient way to make a cup of tea? Raising the temperature of half a litre of water from 20 degrees Celsius to boiling point should take 168 kilojoules of energy, only if you don't waste any. Ranjana is boiling the water using gas, but she'll have to measure how much energy she's using. She's going to weigh the gas container before and after boiling. She used 12 grams of gas. Each gram contains 50 kilojoules of energy, so she used kilojoules altogether. It should only take 168 kilojoules. Could her kettle have been designed better? Kettles can be made so that as much energy as possible water. Joanna is using an electric kettle made of plastic, and she's got the joule meter to tell her how much energy she's using.
It took 214 kilojoules of energy to raise the water to 100 degrees Celsius. If Joanna empties the kettle and refills it right away, will it be more or less efficient?
Is electricity more efficient than gas? Remember, the electricity has to be generated somewhere. Even just for boiling water, energy is a tricky thing to measure. This is a 500-watt microwave oven. How could you work out how much energy it uses? You can't get something for nothing. All methods of power generation have disadvantages. Burning coal can produce the gases which cause acid rain, although the latest power stations are designed to get rid of them before they reach the atmosphere. Hydroelectric power stations have different effects on the environment. And wind turbines? Well, you either love them or you hate them.
You're using an electric kettle, I suppose?
Yes.
They burn coal to make electricity. All that smoke and ash and pollution and acid rain.
They take all that nasty stuff out now. Anyway, how do you know that this electricity wasn't produced by a hydroelectric station? There'd be none of your acid rain then.
No, just flooded valleys and dead fish flapping about on dry land.
What about wind power?
Have you ever heard a wind farm?
Nuclear?
Do you really think nuclear energy is safe?
I don't know.
Impractical. They'd have to surround the whole country with floating objects and things.
You know, they can make electricity out of chicken poo now, you know.
They cannot.
Oh, yes, they can. They burn it.
You can't burn poo.
Have it your own way. There you are.
Oh, thanks. Oh, what is it?
Cold tea.